ערב טוב לכולם, אני רועי חייכל ואני המנהל המקצועי של אגמה. ברוכים הבאים לעוד וובינר בסדרת Quality Time מבית אגמה, והפעם בנושא ניהול סיכוני שיטפונות מבוסס טבע. רגע לפני שנתחיל, נזכיר שגם היום כשאנחנו יושבים בבית ומתכוננים לצפות בוובינר, אחינו ואחיותינו עדיין נמצאים בשבי חמאס, ואנו מאחלים ומייחלים לשובם המהיר הביתה. בנוסף, מכאן נשלח תנחומים למשפחות הנופלים, וכן איחולי החלמה מהירה בבריאות הגוף והנפש לפצועות ולפצועים. הנושא שלשמו התכנסנו היום, ניהול סיכוני שיטפונות מבוסס טבע, מעסיק אותנו לא מעט באגמה. פעמים רבות עולה השאלה כמה באמת הם ישימים, כמה באמת הם יכולים לבסט, כמה הפתרונות האלה באמת יכולים לעזור לנו והם לא משהו שהוא רק nice to have, וכן גם עולה חשש מסוים מההתנסות בהם. במהלך אחת הסקירות המקצועיות הסתכלנו קצת מחוץ לישראל לראות מה יש לעולם לספר לנו על התנסות ויישום של הנושאים האלה, וראינו שגם שם עדיין הם נמצאים בתהליך של למידה. לשמחתנו מצאנו פרויקט מאוד מעניין שקראנו ולמדנו אותו בעצם, שהתרחש בסקוטלנד, שגם יישם אמצעים כאלו בשטח, גם חקר אותם מבחינה מדעית וגם ממש מדד את האפקטיביות שלהם בשטח שמתייחסים לכל פתרון באופן נפרד. לשמחתנו, האיש שהוביל את הפרויקט לאחר פנייתנו אליו, פרופסור קריס פריי, שעסק גם במדידה של הישימות של האמצעים השונים, גם במחקר שלהם וגם ממש בניהול הפרויקט, נענה להזמנה שלנו והוא נמצא כאן איתנו היום להציג את התובנות שלו לאחר מעל לעשור של מחקר ומדידה. לאחר שפרופסור ספריי יסיים את ההרצאה שלו ונשמע לעבודה בסקוטלנד, הצטרף אלינו יואב שרפי מרשות ניקוז שורק לכיש, כדי להציג את הזווית הישראלית של הדברים, מה שבטוח הולך להיות מעניין. אז לפני שנתחיל, נספר קצת על פרופסור קריס פריי. פרופסור קריס פריי הוא פרופסור אמריטוס, והוא אקולוג של בתי גידול מימיים, מומחה לציפורים במרכז אונסקו למשפט, מדיניות ומדעי המים באוניברסיטת דנדי בסקוטלנד, שם הוא עבד במשך עשור, החל משנת 2009. לפני כן, הוא היה המנהל המדעי של הסוכנות להגנת הסביבה הסקוטית, ספה, שאחראית בעצם גם על התחום ההידרולוגי ועל חיזוי השיטפונות ברחבי המדינה. הסוכנות גם אחראית לניטור סביבתי בבתי גידול מימיים, כחלק מיישום הדירקטיבת המים האירופאית בסקוטלנד. משנת 2010 הוא משמש כמנהל המדעי של פרויקט המים של אדלסטון, בתחילה מטעם אוניברסיטת דנדי, ולאחר מכן כחבר ומטעם השותפות האגנית של אגן נהר הטוויד, בה הוא מוביל את המחקר בעצם שעוסק, כמו שציינו, במדידת האפקטיביות של הפתרונות מבוססי טבע לניהול סיכוני שיטפונות. מעבר לכך, קריס הוא חבר במועצת המנהלים של הפארק הלאומי לוך לומונד וטרסקס, ובמועצת המנהלים של גוף ציבורי בשם סטנדרטים סביבתיים בסקוטלנד, אשר אמון על וידוא אפקטיביות החקיקה הסביבתית וזיהוי פערים בין החקיקה המקומית לזו של האיחוד האירופי, שזה בעצם מהלך שנעשה שם לאחר שסקוטלנד עזבה את האיחוד. בעבר הוא גם שימש בתפקיד נאמן במספר ארגונים ללא כוונת רווח, וביניהם המרכז השיקום נחלים, ה-RRC, האיגוד לביולוגיה של מים מתוקים, איגוד האורטונולוגים הבריטי ועוד. כיום הוא ממשיך מתוך מחויבות עמוקה לעסוק בהתנדבות ובפרויקטים של מדע אזרחי הנוגעים לשמירת טבע. אז אני חושב שאני דיברתי מספיק, כי אני כבר רוצה לשמוע מה יש לקריס לספר לנו. So Chris, good evening, if you can join us.
Good evening.
Hi Chris, good evening. How's the weather in Scotland, we have to ask? Is it raining?
It's beautifully sunny. This is very unusual.
I'm happy to
Scotland
hear.
itself a hydro nation, and good reason.
I'm happy to hear. So climate change also arrived there.
Yes.
So Chris, I already introduced you. I talked a little bit about what we're going to talk today, and I said I spoke enough, and now it's your turn. So you're welcome. You can share your screen and start the presentation.
Okay. Great. Hopefully you can see that.
That's perfect.
Fantastic. Well, thank you very much for the invitation to join you. This is probably my first attempt to try and do this to Israel. So welcome from a very sunny Scotland over here. What I'm going to talk about is the Eddleston Water Project. It's a Scottish government-funded project to try and get the scientific evidence base behind what we call natural flood management, but you might call it nature-based solutions or engineering with nature or working with natural processes. But in Scotland, natural flood management, NFM as we call it, recognizes that to try and reduce flood risk, you can't just build a wall round the community, the town, the city at the bottom of a catchment. You have to think in a whole catchment. And being a scientist, we like to think of sources, pathways, and receptors. So the policy in Scotland shifted in 2009 from trying to defend with walls and flood banks the cities and the towns to not only doing that, but thinking, how could we change the characteristics of the catchment, the water basin above the towns? So instead of talking about flood protection, we started talking about flood risk management. And indeed, we now talk about resilience because of climate change. And this is not instead of building flood walls or having flood schemes, it's as well as. So it's taking a whole catchment approach. But to do that, two things happened. We passed a new law in 2009, driven by the European Union, who produced their own directive on flooding. Scotland, I should point out, voted to stay in the European Union. The rest of England and Britain didn't, but everywhere in Scotland voted to join in, and we would quite like to get back in. But we took the opportunity of the EU directive to rethink and bring in our own law. And what's impressive about this law is that it legally requires an organization to ask and to answer the question, how could you change the natural characteristics of the catchment to help reduce flood risk? So you can't get money to build a flood wall unless you also ask and answer that question. And that's Section 20 of our Act. But the parliamentary group, the parliamentary inquiry, also realized that the science wasn't good enough to really answer that. So they required the Scottish government to set up one or more pilot catchments to test the science. And the Eddleston Water is the biggest, longest running catchment study in Scotland and probably in the United Kingdom of its size. So we had two very clear aims. Could we assess the effectiveness of natural flood management measures? Because people knew how well a flood wall would work, but they didn't know how well planting 50 hectares of trees might work, or building a pond, or re-meandering a river. And the second question was, when we're doing this using natural flood management, can we improve, and if so, how, the habitats and species on the river? And the third very important bit was we had to do this voluntarily with the landowners. So nothing I will talk about has involved legal agreements or money going to the landowners, the farmers, for them to carry out these various measures. And that's a very hard thing to work with, but it means that everything we've done, you will see here, is negotiated with the farmers. They don't lose money, but we couldn't put them out of business, if you like. And we'll come back to that right at the very end. So what we aim to do then is to work with the character of the landscape, and we're really trying to slow the flow of floodwaters, to store them temporarily and improve river habitats. And there's lots of different things you could do. You could set back the flood embankments, you could put in high flow logs restrictors, you could build ponds, you could create woodlands, you could re-meander the channel. And the project is an empirical long-term study. It's managed by Tweed Forum, for whom I work now, as well as at Dundee University. And they are a participative charity, non-governmental organization, a rivers trust, if you like, but they've been established for 30 years. They have 19 staff. They do a lot of work, not just in rivers. So they manage it on behalf of the Scottish Government, who provide most of the funding, the Scottish Environmental Protection Agency, and our local regional government, which is the Scottish Borders Council. And then the science comes from the University of Dundee and the British Geological Services. But then we have advisory groups, and we rely entirely on working with the community and the local farmers as well. And so far, we've spent over £3 million, so well over $4 million US dollars on the work, and that's increasing dramatically all the time. So, whoops. Critically, we began with a scoping study way back in 2010, and this is a very important aspect because this is where the University of Dundee came in, and the scoping study produced 4 outputs. One was historical context, what happened, because as you'll notice, that river is very straight. It didn't start straight. Second one was to survey the current state of the environment. And then we were required to design a monitoring network and to develop a stakeholder engagement strategy. And critically also, when we got going, we had 2 years of monitoring before we did anything else. And the catchment is heavily straightened, and this occurred 200 years ago. And one of the interesting scientific things we discovered was that we were told and we assumed that this was straightened to build a railway. In fact, we discovered a map in the ancient museums of Scotland that showed that this was straightened 50 years earlier in about 1800 to build a road. It was the road that caused the straightening, and then the railway came along after it. So it fails all its ecological status tests because the hydromorphology is very impacted. And that colored diagram just shows the level of impact along the river, with red being very heavily impacted of one stretch of river. And Cringlety and Lakewood are indeed the areas we re-meandered when we started. This was very straightened. The water quality is actually pretty good. It doesn't fail for water quality. It fails because of that aspect in relation to, the structure of the river. So we also had to set up a monitoring idea, and we set up a strategic design, which basically we would look from the rainfall, the precipitation, how that impacted the hydrology, both the surface water and the groundwater, how that impacted the river channels, the hydrogeomorphology, and how that impacted the ecology. So we tried to get the whole area. And it really was a very simple attempt to look at what happens if you put a large digger in a river, if you like, and you intervene or you plant trees. What's the process response? What's the structural changes in the river, the sediments, and what happens in terms of the ecology? We had to look at the whole catchment. The catchment is 69 square kilometers, but also to look at the individual measures, the NFM measures. And where we could, we tried to do before, after control impact design of the research. And we also looked at the timescales. So we've now been doing this for 10 years since we did the main meanders. So we're getting a trajectory of how quickly and how fast the ecology in the river responds. We also looked to find what data we got, and our Environmental Protection Agency had data from 2 sites, which gave us another extra 20 years, if you like, of level data in the gauges on the river, a bit of fish data. And as I said, we had this lovely option of 2 years targeted pre-intervention monitoring. There's a lot of other ecology work, ecosystem services, behavior, economics going on, because this is all publicly funded, and therefore it is a research platform which anybody can apply to come and work at. So any or all of you would be very welcome to come along. You've got a model you want to test or some ecology, and we'll look to try and fit you in to this whole thing. It's really useful that it is a research laboratory. So this is what it looks like. It all is based on the underlying comprehensive hydrology network. And if I look at the graph on the left, what we're trying to do is to show that if one has some rainfall, which is this blue pillars starting there, what happens to the level of the river, so the hydrograph itself, the rising limb and the falling limb, how high does it get? How fast does it rise? And what we're trying to do is to decrease the height of the flood and increase the time. So we call that the lag between the rainfall and when the peak goes. And what we've done is to install a very, very comprehensive hydrological river monitoring system, probably the most dense in the United Kingdom for a catchment of this size. So 69 square kilometres. There is a gauge every 2 to 2.5 kilometres down the main stream and all the side streams. There are much more dense systems elsewhere in Britain, but they tend to be for catchments that are only 5 square kilometres. This is much bigger. And what this enables us to do, along with 5 major rain gauges, is to track an individual storm. So the graph on the left at the bottom is the hydrographs from all these different sites, and it shows one storm in August coming down the actual catchment. And it lets us isolate bits of the catchment so we know what's happening. We've also got a lot of groundwater, which I won't talk about as well, but we've got that as well. And we've had all this working all the time since 2010 now. And on the ecology, we took a slightly different approach. We actually looked specifically at what happened if you re-meandered a river. And we've got 2 sites where we've done a lot of re-meandering, the Lakewood and the Cringletea, and 2 sites which we use as controls, one upstream, one downstream, where we've done no meandering. And ecologically, we've looked at aquatic macroinvertebrates, a bit of fish monitoring, but mainly aquatic macroinvertebrates, 2 years before we did the re-meandering, and now 10 years afterwards. And we've even done a little bit of environmental DNA. At the same sites where we did that, we've done a lot of sediment monitoring, looking at the grain size of the channel and the structures in the channel, trying to get a handle on what's happening to the physical structure of the habitat and then what's happening to the ecology. And amazingly, all the macroinvertebrates we collect have been collected by one person, Lorraine Quinn, who works for the Scottish Environmental Protection Agency. So we've removed one of the main areas of variation. It's the same person who's caught all these thousands, indeed 10,000s of invertebrates. And the other thing we did was to say, what would success look like? Because remember, we're trying to answer questions about, do things work? So we started with a whole load of ideas we might try and look at. Some of them we've managed to do, some of them we haven't yet. So with hydrology, it was to look at the flood levels, the flood event frequency, the lag time to peak floods. And in each area, we decided whether we were doing this for the whole catchment or a sub-catchment or individual areas within it, in the meanders or the ponds or whatever else it was. So with the ecology, to jump to that one, we've looked at river habitat types, we've looked at biotic indices, and we've mainly concentrated on macroinvertebrates. We've also got fantastic data on aquatic macrophytes, the plants, which we haven't even yet analysed. One of the problems or challenges of this study is we've got a lot of data. It's been collected, a lot of it by different organizations and our own Environmental Protection Agency, for instance, and they haven't yet had a chance to even analyze some of it. So we've been sitting here with a lot of data still yet to be analyzed, which we're actually trying to do this year. We're doing a lot of efforts to try and do that this particular year. In terms of the ecology, we ought to say this is a special area of conservation underneath the EU Habitat Directive because of the salmon, the otters, the lampreys, and the aquatic macrophytes, the water crowfoot that grows there. So it is a protected site in that one. So what did we do? Well, the first thing we did was we actually scoped all the things we might do. Without talking to any landowners, we actually, as scientists, said, well, we could do lots of different things. We could re-meander the channel, we could build flood ponds, we could take down flood banks, we could block up ditches, we could put log jams in, we could release beavers, we could do all sorts of things in theory. What then happened was that we went and talked to the farmers, and this is where Tweed Forum, as this very well trusted intermediary, this non-governmental charity, who understand farming, went and talked to lots of different farmers, and we've worked so far with 23 in the catchment, and asked them about where we might be able to do some of these new flood ideas, these new measures. And remembering, we're not paying them, we're going to pick all the costs up, we're going to make sure they don't have any costs, they're not going to lose any money, we do all the paperwork, all they have to do is agree. And there are no legal agreements. This is all done by a shake of the hand, a cup of tea, and being Scotland, there might have been some whiskey drunk somewhere along the line. I couldn't swear to that. And then we went out and did things. So here's our catchment of 69 square kilometres. We put in 116 high flow logs restrictors. And the important thing about those is they're in the upper catchment and the water flows underneath them unhindered until it starts rising. So they're different to a beaver dam. They're not a dam, they just sit above, and as the water rises, they catch water. We've put in lots of native trees. It's probably more than that now. I think it's 350,000. We've remeandered at least 3.5 kilometres. Again, that may rise. The main stem is about 16 kilometres long. And we built 38 flood storage ponds of different sizes. There's about 100 ponds in total in that area, and they're all man-made. This is not an area of natural ponds, but we've built 38 specifically. And here's just an idea of how and what the negotiations with the farmers looked like. That is the main river, and it was straightened to be exactly as straight as that dotted line shows. And these are 3 different farmers with 3 different solutions. So the first one at the top at Pringlety is a farmer who is what we call a hobby farmer. And he just asked us, what could we do? And he didn't want very much done. So it's a very shallow meander. The one at the bottom, Lakewood, is really rewilding. We never use the term, but this is a channel that we dug that increased the length of the river by 47%. And the farmer just said, well, you can do what you like. We took down an old conifer woodland. He wanted a pond, so we dug him a pond. But he also did not want that very bright green field to flood. So there's a flood bank there, and that's a silage field, very important to his farming. And then the one in the middle at Milkiston on the left, this is different again, because this is a channel that does not move. And it was done 2 years after the first 2, which is not how you should do restoration. And it's armoured with a lot of rock in there we had to bring in. And the reason being, that is the main road, and we could not let that channel take the main road out. So it was a more difficult farmer to deal with, but it's a very different, that's engineering with nature, whereas Lakewood is virtually rewilding. The trees fell in, it's got otters, it's absolutely fantastic in that area. These are what the structures just look like. Those are the high structures. They're very cheap, very cheerful, very easy. They last about 10 years, and we're currently trying to replace them. That's what tree planting looks like in Scotland. The only thing you're not seeing is the rain falling down. These are some of our ponds. We've put a lot in at the top of the catchment, small ones, connected, and then we've put in one big one. So to come to the end then, and does this actually work? Well, the first thing is that yes, different NFM measures, as we call them, can reduce flood risk. And this is largely through temporarily storing surface waters and delaying flood peaks. So these small log jams, log structures, as we call them, these do effectively delay the flood peak. So this graph at the top shows a rainfall event in the top left-hand corner, and then the lag, that's the time between the rainfall peaking and the river peaking of 4.7 hours. And then there's another rainfall event, and it keeps going. It's much easier if there's only one event at a time. But those small 35 as it is in that one little stream, delay the floods by anywhere between 2.5 and 7.5 hours, just in that one small area. And we know this because we were able to compare what happened in the middle burn, which is where we put all these structures in, and the Shiplaw burn, where we didn't have any. So they were next to each other. And we know that we have these delays. And lag time is a very good measure of what's happening to your floods. It's very transferable. We're also seeing, as it says there, flood peak being reduced by a good 30% before we did this in the upper catchment, and even 8% in the lower catchment. And we've got a paper already published on the first bit. We've got a paper being written at the moment, exploring more on the flood peaks. And what's impressive here is that this is really very small things, very small amounts of engineering. These are very, very cheap structures put in, and they're only in these two little, in the middle burn, right in that northwest corner. And yet we're still picking up the effect by the time you come down to Eddleston, 25 kilometres further down significantly, and indeed up to 36 kilometres, not quite significantly. In terms of the remeandering, yes, remeandering does give you storage on the floodplain. This is the left and right is the before and after. We've done the remeandering at Lakewood. This is a picture of Lakewood underwater. And that adds about 6% extra storage. But what it really shows in particular, though, is that it doesn't work very well unless you take down the flood banks and you allow the river to reoccupy its floodplain. This has been heavily embanked. If you just remeander and you don't do anything else, then all that does is actually add about 2%. It's no more than that. But remeandering does do a lot for wildlife. And here what we've got is a very clear signal of ecological change. For a starter, we've increased the length of the channel dramatically, up to 46%. And they have a much greater diversity of habitats. So this graph below in blue shows Lakewood before we started in 2009, and in red, the 5 habitats in 2016. And what you've seen is 2 dramatic changes. You've got a drop in the glide, which is a very, very undifferentiated flow. You've got deep pools now suddenly appearing, which are very good for climate change resilience because they are much lower in temperature. And you've got a lot of riffles, which are the fast flowing gravel areas with a lot of oxygen, which are very important for breeding salmon and for macroinvertebrates. So you've got this wonderful change here. And what we've seen also is that there's a dramatic change in active bar features. These are the gravel areas that are moving that are most important. And in the restored and the control areas, you've got a very different result, if you like, which is showing what we'd like to see in this case. In terms of the actual invertebrates, as I said, we've got 10 years of data and we're just putting the paper together on that one. They do very rapidly recolonize. There's not a great new type or diversity. It's just there's far more of it and it's far better in the habitats that we've got. In terms of ponds, do they work? Well, yes, they do, but there's a problem of scale here because ponds have to be very large if they're really going to have any fantastic effect. And of course, the minute you fill a pond up, it's no longer doing anything for flood defense or flood risk reduction. A hydrologist would like a pond to have no water in at all. An ecologist would like a pond to always have water. So all our ponds are a compromise. They have between 40 and 60% extra capacity to hold when they flood. And we have a system of pipes and overflow systems that ensures that a pond always has some water, but then can hold a lot more. But our modelling and the latest paper just going into, I think it's being submitted in next month, will show that it's only in very small catchments in the sort of 2 square kilometre, 3 square kilometre that they can have a significant effect. They just don't, they're not large enough and they don't work with large scale events where you've got a lot more water coming. We have got one big pond on the floodplain, and the challenge here is that this is the best agricultural land, and therefore it's unlikely that you can persuade a farmer to actually ever give you this sort of land to create a pond. What you can see is the two diagrams, is the depth of water being held. And what we've done by digging this pond is increase the flood holding capacity from about 3,000 cubic meters of water to 20,000 cubic meters of water. But again, one of the problems is that once it's full, it is full. And although in theoretically we could build a lot more, this is the best farmland, and it's unlikely to be economically or socially or environmentally acceptable. What we have shown, though, is that these ponds we built, although they're designed as flood storage ponds, are very good for biodiversity. And we've had two Swiss students, an example of people from outside coming and doing work here, who've looked at the macroinvertebrates, and most recently one on dragonflies. And that paper on dragonflies was submitted 2 days ago, I'm pleased to say, to a journal. And what they show is that these ponds are remarkably good for biodiversity, partly because the water quality is very good, partly because the habitat round about is very good as well. The terrestrial habitats are very good. They're not intense farmland. So they're as good as some of the best conservation ponds across elsewhere in Britain. So we're really pleased with that work. And in terms of woodland, just to finish off on these, the theory behind if we planted the whole area with woodland is that we could get major reductions, maybe a 20% reduction in flood peak, some work done earlier on. But our most recent modelling work, which I've just seen, suggests far less impact. And what's much more important is what the soil type is underneath where you plant your wood. But what we do know with woodland we've already done is that mature broadleaf woodland takes a lot more of the rainfall, and it infiltrates into the groundwater than the adjacent grazed pasture, this is sheep pasture. So that picture on the right-hand side shows heavily grazed pasture with water after a rainstorm coming pouring out, whereas in the trees, this isn't happening. And the same is true with rough grassland. So they are very important in intercepting rainfall before it even gets to the river. And the other thing we've known with a student last year is that where we've planted trees, we've got localized reductions in water temperature in the region of 1.5 degrees. And this is very important because young salmon in particular are very susceptible to rising temperatures, and we're seeing that in Scotland. Just one quick thing about the monitoring. What was the important messages I'd give to you? I think the most important one is the value of having a scoping study before you do anything in terms of thinking what might happen and getting people involved, because it identified where the best sites would be, the targets for where we might restore things, therefore which farmers to talk to. We discovered some previous data sources, particularly the river monitoring that we were able to add on to. We aligned our monitoring locations and our methods to try and extend that baseline, to try and get a longer ability to talk about the recovery and what's happened. And the monitoring showed us there were sub-catchments with different contrasting topography. So some of the work we're doing at the moment is looking at sub-catchments with very impervious soil and sub-catchments with nice areas of infiltration. So you can build up nice designs. And then the importance of 2 years of pre-restoration. There were some things that didn't work, and perhaps the most obvious one that didn't work was that being an empirical study, we've had to sit and wait for a long time for events to occur. We've built a model which works very well in terms of the flood areas, but we've had to wait for another flood to come along. And we still haven't had a flood as strong as the one we had in 2012 before we started. So it's always difficult if you're using empirical data not to have to wait. And the other thing is we did use methods that were already available for some of the monitoring that have been widely used by the UK environmental agencies. And actually, it might have been more sense to do some quantitative work on our invertebrates ourselves and look at some experimental things. So not everything worked from that point of view. So the summary of what we've got really there in terms of trying to answer the questions we started at the beginning is that, yes, different natural flood management measures can reduce flood risk. And they do this by temporarily storing surface waters and delaying the flood peaks in particular. But you would need an awful lot of them across the whole catchment before you start making any significant difference. And re-emphasizing what other people have shown, and that is that these measures work best in small catchments and in response to lower level flood events. This is not going to stop a flood that comes in at a 1 in 50 year event frequency. And with climate change, of course, that's an increasing problem. And it also doesn't work very well if you have the classic rainstorm after rainstorm after rainstorm. It works best on individual events. But it's all about reducing flood risks with other methods. It's not just about doing that. And key also is that they produce a lot of ecological benefits. And indeed, we've also now got a load of society, recreational access benefits as well. And we've been able to show that the value of this economically. So I'll end up with two things really on this side. And that first one is it good value for money? Which is what every politician always asks. And we can do this. We can assess how much we've reduced the flood risk by using standard methods. And the whole of this work has used standard open access methods on purpose, so it's transferable to other sites. And we know from what we've done by 2021, and we've done more since, that we have a net present value, so that's all the costs taken away plus values, of just under £1 million from flood damages avoided, and that's the area downstream in Peebles that regularly floods. And that's what we've done, but we know just by hypothetically looking at that, we could increase it fairly well to something in the region of just under £3 million if we were to keep doing all the material. So that's one message. Yes, it does. They're not big amounts. But what is interesting is if you then add the value of the other benefits, the ecosystem services from these same measures, they are 4 times as great. And if you think of a flood wall, it just works as a flood wall. It doesn't have any values for education or carbon or biodiversity or amenity, unless you like walking on flood walls, I guess, or water quality or pollution. All of these things you can monetize, and they come up way higher. So our £1 million for what we've done already is you can add another 4.2 million from these other ones. And that footpath in the snow there is now so heavily used. It's dramatic, and the local cafes and the local pubs are really benefiting from that. So we've got this one. And that's what we've done. But what we're doing now is trying to do something quite exciting. And that is, when I said at the beginning, we haven't paid the farmers anything. The question is, if we had the money, could we do a lot more? So what if we could pay the landowners to farm flood defence? So most farming in Scotland requires and relies on public subsidies, and that's how it works. So the debate is, could we actually get farmers to be paid for the flood reduction as opposed to being, or alongside being, paid for producing cheap, good quality food? And this would therefore reduce the flood risk to our downstream properties, and it would have lots and lots of advantages for ecology, and it would start providing climate change resilience. And the question is, could we get this money from the private sector, i.e. from the people who might be flooded? And in Scotland, we have this rather badly named Facility for Investment Ready Nature in Scotland. And we've got £250,000 from them to try and explore whether we could create a green finance market that we would get money from the people who would benefit from the reduction in flood risk actually to pay the farmers. So can we get a revenue stream for the farmers? So instead of saying you don't lose any money, could we go to a farmer and go, if you allow this field to flood, we will pay you £400 per hectare per year, something like that. So ourselves as Tweed Forum, along with our modelers, JBA and Finance Earth, who are a very expensive London-based, Edinburgh-based financial investment company, have been working and taking a lot of assistance from the Rivers Trusts elsewhere in the United Kingdom to see if we can do this. We have a meeting tomorrow. This is real live stuff. But this is where we've got to, my last slide. What we've done is we've used our model to actually ask the question, if we wanted to reduce the flood risk in Peebles, the downstream flooded area, for a 1 in 30 year flood, so we've set ourselves some targets, by 20%, how many NFM measures would we have to put in and where would they be? So the modelers have gone back and they've modeled 4 different types of thing we might do. We might have runoff retention features. We might get the channels to flood more, have better storage in the area, or we plant a lot of woodland. And what that is showing us, the map on the right shows 4 zones which have different priorities. They have different impact on downstream flood impact. Sorry, the flood impact in the downstream community. And the different colours are the different types of things we might put in. And the ones in the floodplain are the floodplain storage, where you divert the river onto the floodplain deliberately. And that, which is a very accurate model because it's built on all those years of data, shows it could be possible to reduce the flood risk in Peebles by up to 40%. And that's a significant amount just from doing natural flood management. And the main gains are from enhancing floodplain storage, so reconnecting to the floodplain. The farmers would still farm, but they would be paid for this. Now, is that possible? Well, the answer is yes. If you go south of the border into England, and we have different policies for areas like environment in England and Scotland, England have just offered the farmers, as part of their subsidy systems, upwards of £1,400 per hectare to enable their riverside fields to flood, and for a contract for 20 years. And that's coming from the public subsidy. But there are also a couple of rivers trusts south of the border who have raised money from the downstream communities, from the industries, from the local councils, from large companies wanting to offset their biodiversity impact, environmental gain, and actually have got large amounts of money, which they're also now providing and presenting to farmers. If we could do that, we could then really change what we could do in our catchment. And that's what we're just exploring. Where we get to this, I don't know. Come back in a year's time, we'll tell you where we got to. But so far, the modeling is proving very interesting. And the final thing to say is this has more data in it than almost anywhere else has. What we need to do now is take our model and take what we've learned and try it out in the catchment immediately to the west, where there's no data, except for publicly available data, and see what we can get to there. So thanks very much indeed. That's all my talk from my point of view, and I'll stop sharing now.
Thank you so much, Chris. It's not the first time I heard the talk. It's the first time I see the new slides you added in there. And I will start with the first comment. I always say, looks like we need to come and visit because it looks amazing. It looks like an astonishing work. So many measures implemented, measured, studied. I will just invite Yoav to join us in the meanwhile, while we chat. As Yoav, אתה מוזמן לעלות בינתיים. And I think the combination of so many organizations that allow you also to work, also to study. You talked about papers going out. I think it's just amazing. And I just wanted to ask, you maybe answered it a little bit in the new slides, because you started with some knowledge gaps and a certain uncertainty, and you had to sell it to the local farmers. And today you know better. So I think one question would be, how did you convince someone to take a measure in this field when you can't really promise them your final result?
The answer is by using Tweed Forum as this very trusted intermediary. So we have a meeting with the local community every couple of years. We invite them into the village hall. We provide lots of cake and coffee, and we don't allow any academics, any government people, any environment people. It's just two of us from Tweed Forum, and we explain to people what we're doing. We explain the results, and we do not try and sell them anything. So that's the first thing, is we don't pressurize anyone, and we just rely on talking to folk. And sometimes it takes 2 years before they come back. Sometimes, there are people who have agreed to big schemes and then said no. Sometimes it requires someone to leave, to sell, to die. We're always hoping there'll be some young female farmers. I mean, most farmers in Scotland are old and male, as many places, I'm sure. But the new generation is really key to us, and we just have time. We just have to wait, and it's about trust, and it's about Tweed Forum knowing where to talk and when not to try and press things, and making it easy. As I say, we do all the paperwork. We do all the money up front. You could not do that if you were an agency or a government. You'd have to have a lot of differences. And we've lost money on a couple of occasions, and we've had to go back and change the mistakes. But the individual farmers see what other farmers do. That's what's really important. If you've got one, they then look at it. It's not showing them clever models. It's actually about them learning from other farmers. So
if I heard correctly, I hear patience, and you said before whiskey. So maybe
that helps.
Maybe you should send us some Scottish whiskey, and it will work here as well.
Probably. One of our best exports.
So I invite יואב שרפי, מנהל מחלקת תכנון וסביבה ברשות ניקוז שורק לכיש, to give his talk, and he will continue our talk about farmers, but let's see what's happening here in Israel. Sorry, Chris, this presentation will be in Hebrew, but you're welcome to stay with us. I think there are a few questions in the Q&A, so you're welcome if you want, you can answer them. יואב, כמו שאמרתי, מנהל מחלקת תכנון וסביבה ברשות ניקוז שורק לכיש, שמחים שאתה איתנו פה היום. הבמה שלך, להציג את הזווית הישראלית.
תודה רועי, ו-thank you very much, Chris. It was really fascinating. אני לא צריך לדבר על הקשר עם החקלאים, כי קריס עשה את זה מצוין, אין הבדל. אנשים הם אנשים, סקוטים, ישראלים, מבוגרים, גברים, ומשתנה. ואנחנו מקבלים הרבה עזרה מהשטח, ויש רוחות של שינוי, אני אתמקד בהם. ואני רוצה, אחרי כל ההצגה של התוכנית האגנית המרתקת והמגוונת והשלמה של קריס, אני אציג אמצעי אחד שאנחנו מתנסים איתו, ונראה שעובד טוב. אנחנו ממש בתחילת הדרך, אז אני לא מציג תשובות כמו קריס, אני אציג בעיקר שאלות ותקוות. אז הסיפור שלנו מתחיל בבני ראם, באיזשהו אירוע. אני מתחיל מלמטה כי פשוט נזקים שדרשו מאיתנו להגיע לשטח ולהתערב. אתם רואים בתצ"א כאן איזושהי תעלה מאוד טיפוסית, תעלה שהיא בעצם הטיה של נחל טבעי. רואים את השרידים של תוואי הערוץ, חוצה את השדות וחוצה את המשקים, שהוקמו בשנות ה-50 ולכבודם מתו גם את הנחל. באירוע מאוד גדול של 300 מילימטר ביממה, הערוץ חזר לנתיב המקורי שלו, כמו שאנחנו מכירים, סיפור גנרי קורה הרבה, במיוחד עכשיו עם אגנים קטנים שהולכים ונהיים יותר אגרסיביים, ואירועים יותר קיצוניים בעוצמות. אז התבקשנו לייצר איזושהי סוללת הגנה, שאתם רואים פה באדום, ובצהוב איזושהי מערכת ניקוז. אז יש שם איזשהו נתז, היו שם שני צינורות של 60 סנטימטר, והתבקשנו להגדיל את הניקוז בצורה משמעותית כדי שלא יהיו הצפות. ובשיתוף פעולה עם החקלאים, ואחרי הרבה מחשבות ביחד, ביקשתי לנסות לצמצם את הניקוז, ובעצם להציף את השטח שמעל הסוללה, וככה זה נראה כשזה עובד בשטח. סוללת הגנה מאוד מתונה, מעובדת, שמקבלת אירוע מאוד מאוד משמעותי, בתחתית הסוללה, בנקודה הכי נמוכה של השדה, צינור, גם בצד השני מול הלולים, סוללה מאוד מתונה. הצינור משחרר כל הזמן ספיקות מאוד מתונות, ומאפשר הערמות של מים לאחור, ובעצם השדה הופך למעין מאגר ויסות. מאגר ויסות, השחרור למורד הוא קצת יותר גדול. אז ראינו שזה עובד, קיבלתי גם את התמיכה, ואגב, ממשרד החקלאות שמימן את זה, אלון מאור בשימור קרקע, וקיבלנו רוח גבית להמשיך ולנסות להשתמש בטכניקה הזאת לבסט ספיקות, וכאן קיבלנו כבר כספים קצת יותר גדולים, העולם של הניקוז, התחלנו להתנסות עם סוללות שונות, כל מיני ניקוזים, כל מיני אגנים. פה אתם רואים סוללה שהוקמה כבר במושב ניר חן, בשדות החקלאיים. בעצם כבר קמ"ר וחצי של ערוץ, זה לא השדה שראיתם קודם, שהוא היה אגן של 300-400 דונם, פה אנחנו מקבלים כבר סדרי גודל אחרים, שהמערכת פה היא בעצם הכוונה שלה היא צמצום נזקי שיטפונות. בעצם הרצנו פה איזשהו מודל הידרולוגי שמראה ספיקות, פה אתם רואים הסתברות של 1%, והנחתה של הספיקה והלג שקריס דיבר עליו, אנחנו מורידים פה ספיקה ב-50% מהסתברות, זאת טבלת ההסתברויות של האגן הספציפי, אתם רואים אותו ב-B2, זה אגן של קמ"ר וחצי, שאנחנו מנחיתים את הספיקה מספיקה של הסתברות אחת ל-100 שנה לספיקה של 20%, שבסופו של דבר התנסינו עם עוד הרבה סוללות, כל מיני גדלים, כל מיני ספיקות, צינורות של 40 סנטימטר, צינורות של 60 סנטימטר, 80 סנטימטר, בכל מיני גדלים של אגנים, מ-300 דונם עד קמ"ר וחצי. סוללות מורכבות, זה למשל דוגמה ממושב הזריקם, במורד הספיקה, במורד האגן החקלאי, זה למושב, יש בית שמוצף כמעט כל שנה, ובנינו מערכת מורכבת של סוללות עם מעברים פנימיים. הצינורות הכי גדולים פה הם של מטר, שהרעיון הוא שבסופו של דבר כולם מתנקזים עד הסוף. זה למשל סוללה ליד הרחבה של נגבה, שאנחנו מרסנים בתוך השדה, ואנחנו מנסים גם, עכשיו כל הזמן הזה אנחנו מדברים על ההסתברויות הגדולות, אני חוזר רגע אחורה, כי ההסתברויות, כל ההסתברויות שנמצאות בטבלה הזאת הן בעצם ההסתברויות הנדירות, ואנחנו לא מדברים בכלל על ההסתברויות השכיחות, ובעצם אני מנסה להסתכל על הצד השני, אני מנסה להסתכל על קציר הנגר ועל השימוש בנגר, כי בסופו של דבר אני חושב שהשורה התחתונה של קריס זה להגן משיטפונות, זה לא מספיק, זה אפילו לא מצדיק את עצמו. צריך להסתכל גם על התועלת, על התועלות. התועלות פה לא נבחנו. עכשיו, קשה לי, האמת, אני נורא רציתי להראות את הסוללה הזאת מלאה, אבל אנחנו לא מצליחים לתפוס אותה בכלל מלאה. כי ההסתברויות שהיא מתוכננת אליהן, הן נדירות כל כך שאנחנו כמעט לא רואים את הסוללות מוצפות, הן מתנקזות בדקות שאחרי השיטפון, ואנחנו לא מצליחים לראות את זה מלא. רואים רק סימני C, ממש דקות של האירוע. ואז חשבנו איך אנחנו עושים בשביל לקצור את הנגר, וניסינו לצמצם, ואנחנו הולכים ומצמצמים את הספיקות יציאה, ומחפשים את הספיקה הנכונה לוויסות, שבה נשתמש כל שנה. אז זה ניסיון בני יעקבי כעס עלינו, והוא כנראה צדק. ריסנו עם פילטר שמשחרר את הסליקה בשעות רבות, ואז קיבלנו אירוע של 13 ימים ברציפות, שבועיים עמדו פה מים בשדה, כל מיני צמחייה, אני אשמח אם מישהו פה יעזור לנו בצ'אט, וננסה לזהות צמחים שמופיעים בקרקעות כבדות, צמחים שאנחנו מנסים להשיב לבטל גידול אחיו, אבל חקלאות לא גדלה פה. ואז נשאלת השאלה, איך מרסנים, כמה מרסנים, בעיקר שאלות, עוד פעם, אין לי תשובות, אבל אני יודע שהבית שבמורד הסוללה הזאת, שמוצף כבר פעם שלישית רצוף, לא ראה שיטפון, ואתם רואים את הכרובית ברקע, יש עכשיו דיונים מי צריך לשלם עליה, זה מבוטח, מי נושא בנזק. אני רוצה להוסיף נקודה, בסופו של דבר אנחנו מקבלים את כל הסחף במורד, אני חושב שבסופו של דבר לאורך שנים אנחנו נראה שיפור של פוריות הקרקע ושל המצב, בכלל של מצב הקרקע. אנחנו עוד לא יודעים, אין לנו נתונים, אנחנו מחכים, אבל כן רואים, המערכות שלנו נסתמות בסחף. אני מדגיש, זה לא מחליף את הדבר שצריך לעשות, את הטיפול האגני, זה רק חלק ממערכת גדולה. פה אנחנו רואים את מה שבאמת צריך לעשות, לתפוס את הנגר ואת הסחף במקור, וגם בתחום הזה אנחנו רואים יותר ויותר חקלאים צעירים וטובים שמצטרפים למסע הזה, גם אפילו בחוכובה, זה דוגמה מהחוכובה של גלאון, וכולה מחופה בצמחייה, שזה חזון אחרית הימים מבחינתי. וזהו. אני אשמח לשמוע שאלות.
תודה רבה יואב, שנתת לנו טעימה ממה שעושים פה אצלנו. כמו שאמרת, אנשים הם אנשים, ובסוף אתה בא ומציף למישהו את השטח, אני חושב שזה לוקח רגע.
כמה הרבה רגעים, אבל לא רק רגעים, אני חושב שהחלק הכי חשוב זה שאתה נשאר ואתה לוקח אחריות. אני מדבר רגע על אחריות, כי להישאר ולתחזק את המערכות שלך מאחוריך, ולדאוג לחקלאים שאתה לא משאיר אותם לבד, זה אחד ממרכיבי המפתח, אני חושב, בשיתוף פעולה איתם. אבל יותר מזה, לקחת את האחריות ולייצר את הסוללות האלה, כי אני אומר לך את האמת, קודם כל אני חייב תודה ענקית לבועז כהן, שכמהנדס לקח את האחריות על מתקנים כאלה, זה לא מובן מאליו בכלל. ויותר מזה...
אני אקח לך לשנייה, רק תוכל להוריד את השיתוף ואז גם נראה אותך.
כן.
תודה, סיימת להודות לבועז.
ואני חושב שיותר מזה, לקיחת האחריות על לבצע כאלה מתקנים, איך הדוגמה, כבר כמנכ"ל, בועז מגיע לשטח עם יועץ משפטי שאומר, הם לא נורמליים, הייתה פה הצפה לפניכם, עכשיו יצרתם את הפתרון, בעצם לקחתם אחריות על הנזק שהיה לפניכם. ושאלת האחריות, מי אחראי, זה כמר וחצי, זה שלי, זה של המועצה, זה של המועצה האזורית, זה של הוועד החקלאי, זה של החקלאי עצמו, הוא צריך להגן על עצמו. אין לי תשובה, זה המון המון שאלות, ואני חושב שאלות מאוד חשובות שצריך לשאול אותן בקול, ולמצוא פתרון, אני יודע מה התשובה שלי, אני לוקח את האחריות. זה לא מובן מאליו, וצריך, אני חושב, לפתור את זה ברמה יותר גבוהה. בטח כשחברות ביטוח לא מוכנות לבטח אותנו, לנוכח התביעות האבסורדיות והרבות.
עלתה גם שאלה בדיוק על הנושא הזה לקריס בצ'אט. אני חושב שזה נושא שמעסיק המון מדינות ולא רק ישראל. כל הנושא הזה של ביטוח נזקי שיטפונות וכן הלאה, וזה נושא שלפתחם של המון מקומות ולא רק אצלנו, אז מעניין לראות איך זה יתפתח. Chris, if you're still with us, you're welcome to join us.
Yeah.
אני רואה שאלה שאני...
Great.
So I've been happily typing answers as fast as I can.
Perfect. Thank you. So I think we're about to finish. So we'll give you a minute for you and for Yoav to give your last take-home message, the key points. I think, Chris, if you can share with us a little bit of what are the main things we need to look at when we go and want to implement this type of project here in Israel or in general. And Yoav, אם אתה יכול לשתף אותנו קצת במה אתה צריך כדי שנוכל להביא פרויקט כזה, כמו שראינו נגיד אצל קריס, קצת יותר גדול, קצת יותר רחב וממש ליישם. So, Chris.
I think the key thing probably is being very clear what your objectives are at the start and how you're going to measure success. And don't try to do everything. We were very lucky. We had lots of different areas, but actually having a very clear question that you're trying to answer is way more effective than doing a lot without the proper setup of a research design. So if you're actually interested in research, it's being very clear about the question you're asking and will the design of your project answer it. Ours is a top-down project. A lot of really good ones are created by communities bottom up using citizen science. The quality of the science evidence is never so good. The results are brilliant, and one shouldn't decry them because they're not an academic evidence-based organization. But I think if you're sharing with other people, just being very honest about what you tried to achieve and what you didn't and you haven't looked at. We haven't looked at anything to do with carbon. We haven't looked at anything to do with soil structure. And yet that's probably pretty important in Scotland. We just haven't had the ability to do it. So that's key. And then having time beforehand, having a before that you can do, which has got different sorts of areas and different places, that always helps. So you've got time to actually do things. So time is probably the biggest thing in all of that, but being clear of what you're trying to do. But come and visit. Very happy to take any of you down.
I would just add, Chris, that I think that when I saw your presentation, it was really nice that you showed the whole project and not only the measures. And there you saw how you did the preparations, the screening of the area before, and the objectives, and what you're heading for. And I think it's really important, and it's also interesting you gave it now as your key points. You didn't talk about the measures, you talk about how to build a proper project in general. So I think those are good points for anything we do.
I think the luxury we had is that with Tweed Forum, we didn't have to finish it in 3 years like a PhD or in 3 years of a government funding grant. We've kept going, which is a luxury. Very nice, though.
It's nice to know you can finish a PhD in 3 years. Thank you, Chris.
Well, maybe the field work. I didn't.
No one. That's fine.
No.
Yoav?
Just exactly the same time, because the past started. We started a long journey, and I have all the support from the Ministry of Agriculture. And I was asked about Ministry of Environmental Protection, and they also are involved, not specifically in these tools because it's very agricultural. But yes, we need a lot of time and cooperation. I think with time and with the results, farmers they adapt really fast if it works. And we have to just adjust and polish the tools so it will fit, and it works.
I guess the other one thing I would stress maybe is Scotland is a very small village. We all know each other. We are half an hour from Edinburgh. So on a Friday, you can get the minister to come down because she likes to visit places. We have had every environment minister, agricultural minister, flooding minister. We have had all the directors of the Scottish government. It's very easy for them to come. So it enables us to influence policy and money, which ultimately is...
You have flooding minister. We have a flood of ministers.
Yoav, I think we can top that joke. So I will, again, thank you so much, Chris, for joining us, not for the first time. It's amazing, your cooperation, you're willing to come and be with us today. Yoav, thank you so much, תודה רבה על הצגה של הזווית הישראלית, בהצלחה כמובן בפרויקטים העתידיים גם. And thank you for all the attendance, תודה לכל מי שהגיע וצפה והשתתף. הוובינר הזה מוקלט, אפשר לצפות בו מאוחר יותר ביוטיוב. Chris, I just said this is recorded and afterwards it will be in the YouTube of Agma, people can see it. והמשך ערב נעים, שיהיה סוף שבוע שקט, ותודה לכולם. להתראות.
להתראות.
Bye, Chris, thank you.
Great, thanks very much, hope to see you. Take care.